Imagine a pollution problem in our oceans so pervasive it's invisible to the naked eye. Particles smaller than a grain of salt, floating everywhere. A recent study published just days ago in Nature has revealed that the North Atlantic Ocean alone holds an astonishing 27 million tons of nanoplastics. That's more plastic than all the visible debris we've ever counted. This is the story of the hidden plastic crisis and why we must act now. Let's define what we're talking about. Nanoplastics are plastic fragments under 1 micrometer in size. That's 1,000th of a millimeter. Even microplastics, those under 5 millimeters, are huge compared to nanoplastics. These tiny particles behave differently. They can cross cell membranes, move into tissues, and enter food webs in ways larger plastics simply can't. Nanoplastics can consist of common polymers like PET, PS, and PVC, often laden with chemical additives like phthalates or flame retardants. They're not just small, they're chemically reactive, surfaces for pollutants, and biologically accessible. So, how did scientists discover this underwater cloud of plastic? In November 2020, scientists aboard the Dutch research vessel Pelagia collected water samples from 12 locations across the North Atlantic Ocean, spanning gyres, open ocean, and coastal shelves. They sampled at 3 critical depths: 10 meters, 1,000 meters, and around 30 meters above the seabed. Using ultra-fine filters and advanced spectroscopy, they measured concentrations of nanoplastics in milligrams per cubic meter. They detected 1.5 to 32 milligrams per cubic meter across the water column. On average, around 18 milligrams per cubic meter in the surface layer. When scaled up, that equals roughly 27 million tons of nanoplastics, just in the top portion of the North Atlantic. Even more surprising, nanoplastics were found near the coasts, at mid-ocean gyres, and deep underwater, suggesting that this problem isn't just floating on the surface. Why is this explosion in visibility important? First, nanoplastics outweigh micro and macroplastics by orders of magnitude, making them likely the dominant form of plastic pollution in the ocean. But their ecological impacts could be even more dramatic. Because of their tiny size and sticky surface, nanoplastics can enter plankton cells in fish tissues, disrupting biological processes, transport toxic chemicals like heavy metals and persistent organic pollutants, cause oxidative stress, inflammation, and DNA damage in marine animals, move up the food chain from plankton to fish, birds, and eventually to humans. This means ocean life is constantly exposed, not to large floating bottles, but to microscopic, persistent threats. Let's shift to us, humans. Brain tissue studies found significant amounts of plastic in human brains, up to 30 times more than in the liver or kidneys. Animal studies showed that polystyrene nanoplastics can lead to liver damage, insulin resistance, and metabolic dysfunction. Inhalation and ingestion are now common routes. We breathe them in from urban dust and clothing fibers. We ingest them through seafood, tap water, and even salt. Nanoplastics can cross the placental barrier, entering unborn children. The implications are still unknown, but researchers are deeply concerned. While more studies are needed, the evidence so far is unsettling. The plastic problem is not just out there, it's inside us. So where are all these particles coming from? Breakdown of larger plastics over time through sunlight and wave action. Urban sources like tire wear, laundry waste, tea bags, and food packaging. Atmospheric transport, where plastics are carried by wind and sea spray, falling back into oceans or inland areas. And subsea cycling, where particles sink, mix, and are pushed back towards the surface. And although this new data focuses on the North Atlantic, researchers believe similar or worse conditions exist in the Pacific, Indian Ocean, and even polar regions. We're likely just scratching the surface. But despite alarming discoveries, science still has a long way to go. We don't fully understand the toxicity of nanoplastics over decades. We lack standardized global monitoring systems. Detection tools are expensive and sampling methods vary, and perhaps most critically, we don't yet know how to remove them from natural environments. But this research has ignited global momentum. More funding is being directed toward plastic alternatives, safer materials, and circular waste systems. Now we know, the real plastic crisis may not be the garbage we see, but the invisible threat we can't. If you learned something new today, consider subscribing to this channel. Every week we bring deep science stories that matter to your world and your future. And remember, the smallest actions, like refusing single-use plastics or supporting smarter policies, can lead to the biggest waves of change. Together, we can make the invisible visible and protect the oceans for generations to come.